Hello everyone, I'm Mr. Moyavi, one of your grade 12 advanced maths teachers. In our last lesson, we talked about the derivatives of trig functions. In today's lesson, we'll be talking about the derivatives of exponential and logarithmic functions. The derivatives, it's a gradient function that we are trying to find. So just like previous lesson, we will use the standard results here. So if we have the function y equals e raised to the power of x, then the derivative of this function dy over dx will be equal to the function itself, e raised to the power of x. That is the standard result that we must remember because we'll be using this. Right, if I have ln or natural log of x, then the derivative of this function dy over dx will be equal to 1 over x. Okay, I'd like you to remember this standard result here because we'll be using this to find the derivative of some composite functions that involves exponential and logarithmic functions. Right, so if I have example 1, y is equal to e raised to the power of 3x. Okay, I see that the exponential function contains or involves another function in the exponent. Right, so what we will do is we will apply the chain rule that we have learned in the previous lessons. So if I let u is equal to 3x, then this function here becomes y equals e raised to the power of u. Right? So after that, we are now going to use the chain rule to work out the derivative of this function. All right, so dy over dx, using the chain rule again, we can restate the chain rule again, dy over du multiplied by du over dx. All right, so if I have to work out the derivative of this function, I work out the derivative of this function, which is this one, and then work out the derivative of this function, which is this one. Right, so this will be the derivative of this function using this result here. It will be the same, e raised to the power of u, multiplied by the derivative of this function here, u equals 3x, it will be 3. Right, so finally we can say 3 multiplied by e raised to the power of u, but u is actually 3x. Therefore, the derivative of this function here is dy over dx is equal to 3 times e raised to the power of 3x. Right, so that will be our answer. Now let's take a look at another example. Let's say this is example A, so let's take a look at example B. If I have this function y equals e raised to the power of, let's say 2x squared plus 3. I see that this exponential function contains another function in the exponent. Therefore, what I will have to do is I will have to substitute u in this function for this one. So it will be u equals 2x squared plus 3. Once I do that, this function now becomes y equals e raised to the power of u. Right? Now the next part is to differentiate using the chain rule. So dy over dx is equal to the derivative of this function. Again, it remains the same using the standard result here, multiplied by the derivative of this function will be, using the rule for differentiation, we'll find that it will be 4x. Right, so we will have 4x multiplied by e raised to the power of u, but u is actually this function here, 2x squared plus 3. So this is our answer for this function here. Or we can say this is our derivative of this function. Right, let's look at the second example. That is to do with logarithms. If 5y is equal to natural log of 5x plus 2, let's say in bracket, then again the natural log function here involves a function, or it includes another function. So we say we let u is equal to 5x plus 2. Right, so the function, this function here now becomes natural log of u. Right, if I have to work out the derivative of this function using this 2 of this function, it will become what? The derivative of this function multiplied by the derivative of this function. So again, going back to the standard result, if I have to use this result here, for this, it will be 1 over u multiplied by the derivative of this function is 5. Right, so it's like 5 on 1 times 5 is 5 divided by u. But u is actually this function here, 5x plus 2. Right, so the derivative of this function here is 5 on 5x plus 2. Right, let's take a look at another example. If I have a natural log, y equals natural log of, let's take 4x squared. Okay, once again, this is a log function, but it contains another function. So we are going to let u is equal to 4x squared. And we rewrite this function y equals ln of u. And then we apply the chain rule. The chain rule is this. This rule that we are going to apply again, don't forget. So by using the standard result, the derivative of this function by this standard result here, it will be 1 over u multiplied by the derivative of this function is 8x by using the rule for differentiation. Right, so 8 times 1 is 8x, 8x times 1 rather, is 8x divided by u. U is actually this function here, so we'll have 4x squared. Right, so we can leave our answer as it is. And this brings us to the end of our lesson. So what we have actually learned is by using the standard result here for the exponential and log functions, and also using the chain rules, we can differentiate given any exponential or log functions. Right, thank you. This brings us to the end of our lesson, and in our next lesson, we'll talk about integration, and specifically it will be definite integrals that we will discuss. Thank you, everyone.